Hello, students, and welcome. Have you ever wondered what everything around us, your desk, your book, the air you breathe, is truly made of? For a very long time, we thought the answer was the atom, a tiny, unbreakable ball. But what if I told you that the atom itself has a secret, hidden world inside it? Well, today we are going on a journey to explore that world and meet the tiny particles that build our reality.
So here is our plan for today. We will start by looking at the first clues that made scientists doubt the old idea of an indivisible atom. Then we will follow the story of how the electron and the proton were discovered. After that, we'll look at the very first attempt to draw a picture of the atom, and we'll also understand why that first picture was not quite right. And finally, we will do a quick recap of all the key discoveries we've discussed.
All right, let's begin. For a very, very long time, the atom was thought to be the final destination, the smallest possible piece of anything.
Now, you will remember from your previous classes, John Dalton's atomic theory. It was a fantastic theory. It said that all matter is made up of tiny particles called atoms, and these atoms cannot be divided any further. This idea of a solid, indestructible sphere was the foundation of chemistry for many, many years. But, you see, science is all about asking questions, and some simple things that we see in our daily lives just didn't fit with this idea. Take static electricity, for example. If atoms really are solid balls that can't be broken, then how do you explain that small shock you sometimes get from a doorknob, or how a balloon can stick to the wall after you rub it on your hair? Think about this. You have all tried this, I am sure. If you take a plastic comb and run it through your dry hair, and then bring it near some tiny bits of paper, what happens? The paper pieces jump up and stick to the comb. This simple activity was a huge clue for scientists. It suggested that by rubbing two objects, something gets transferred from one to the other, making them electrically charged. And if a charged something can come out of an atom, then the atom can't be indivisible, can it? It must have smaller, charged parts inside. So this idea that there were smaller, charged particles inside the atom started a new chapter in science. It led to many experiments that would change our understanding forever. And the very first piece of this new atomic puzzle to be discovered was the electron. And the credit for finding this first piece goes to this man, the British physicist J.J. Thomson. Around the year 1900, his brilliant experiments confirmed that the atom was not the smallest particle. He had discovered the very first subatomic particle. He called this particle the electron. So, what is an electron? Please note this down. An electron, with the symbol E with a little minus sign, is a subatomic particle. That means it is inside the atom. It has a negative charge, and very importantly, its mass is so incredibly small that for our calculations we consider it to be negligible, almost zero. This was a truly revolutionary discovery.
Now, this discovery immediately raised a new question. We know that atoms as a whole are electrically neutral. They have no charge. So if they contain a negatively charged particle, the electron, then logically there must be some positive charge inside to balance it out, right? And so the hunt began for the electron's positive partner.
Interestingly, the clues for this positive particle had actually appeared even before Thomson discovered the electron. In 1886, a scientist named E. Goldstein was working with gas discharge tubes. He noticed that while some rays, the electrons, were moving from the negative plate to the positive plate, there was a new kind of radiation moving in the opposite direction. He called these canal rays and found that they were made of positively charged particles. This discovery led to the identification of our second subatomic particle, the proton. A proton, whose symbol is P with a little plus sign, is a positively charged particle. And its charge is a perfect match for the electrons. It is equal in amount but opposite in nature. So we say the proton has a charge of +1 and the electron has a charge of -1. So let's just quickly compare our two new particles. In terms of charge, they are perfectly balanced. The electron is -1, the proton is +1. But when we look at their mass, it's a completely different story. We say that the proton has a relative mass of 1 unit. The electron's mass in comparison is negligible. In fact, a proton is almost 2,000 times heavier than an electron. To help you picture this huge difference in mass, look at this slide. Imagine a heavy leather cricket ball is the proton. You know how heavy that feels. Now, in comparison, the electron would be like a single tiny feather. That is the scale of the difference. This is a very important point to remember. Almost all of an atom's mass comes from its protons. Okay, so by the early 1900s, scientists had two particles, the heavy, positive proton and the very light, negative electron. The next big question was, how are these particles arranged inside the tiny atom?
This was the great challenge. If an atom has positive parts and negative parts, how do they all fit together? Are they mixed up? Are they kept in separate areas? Many scientists had ideas, but the first major attempt to create a model of the atom came from the man who discovered the electron himself, J.J. Thomson.
Thomson proposed a model which is famously called the plum pudding model. Now, a simpler example for us to understand it is a watermelon. He suggested that you can imagine the atom is like a watermelon. The positive charge is spread out everywhere, just like the red, fleshy part of the watermelon. And the tiny negatively charged electrons are stuck inside this positive sphere, just like the black seeds are stuck inside the watermelon.
So let's break down Thomson's model into two main points. First, he proposed that the atom is a sphere of positive charge and the negative electrons are embedded or stuck inside it. And second, he said that the total amount of negative charge from all the electrons is exactly equal to the total positive charge of the sphere. This was a very crucial point because it explained why atoms are electrically neutral.
But even with this model, there was one more puzzle. When scientists carefully measured the mass of different atoms, the numbers didn't add up. The protons and electrons together were just not heavy enough to explain the total mass. There seemed to be some missing mass. This mystery was not solved for many years, until 1932, when another scientist, James Chadwick, discovered a third particle. He found the neutron, which had mass but no charge at all.
So, Thomson's model was a very brave first attempt. It was a good start. But remember, science is all about testing ideas and improving them. And soon, other experiments started to show the problems with the plum pudding model. But first, let's give the model the credit it deserves. Its greatest success was that it gave a very good explanation for why atoms are neutral. This idea of balancing positive and negative charges was a huge step forward, and it's a core concept we still use in chemistry today. But a scientific model must explain all the observations, not just one or two. So, the big question was, could this simple watermelon model, with everything mixed together, explain the results of new experiments that other scientists were trying? And the answer from other scientists was a very clear no. The model simply could not explain the results of these new experiments. The most famous one was Rutherford's gold foil experiment, which gave results that were so shocking that they completely shattered the plum pudding idea. But that incredible story, well, that is for our next lesson. So let's pause here and quickly summarize everything that we have uncovered today. We have traveled from the idea of a simple, indivisible sphere to an atom that is full of smaller, distinct particles. This table is an excellent summary for you to put in your notes. We have the electron, discovered by J.J. Thomson, with a charge of -1 and negligible mass. Then we have the proton, whose discovery is linked to E. Goldstein, with a charge of +1 and a relative mass of 1 unit. And finally, the neutron, discovered by J. Chadwick, with 0 charge and a mass of 1 unit. These are the 3 fundamental building blocks of the atom. And so we are left with a very big question. If the atom is not like a plum pudding, then what is its true structure? How could you even design an experiment to look inside something so unimaginably small and find out its hidden secrets? Join us next time to find out the answer. Thank you.